All right, statistics, here we go. This is Coach Lowe again, and we're going to get you through 7.9 inverse norm using the graphing calculator. And kind of like my last set of notes, this is going to look a little crazy. And so I have added little snippets from the graphing calculator to help. There are definitely different ways you can look at it. So I'm just going to try to explain it the best I can. On this screen, uh, really, all they want to know is they want you to fill in um, your curve with these. So sketching the distribution for this normal curve, and they just want you to label all these. So we're just going to make this really fast, and we're going to move on. So basically, you got the mean right here, and just going to put an X bar. There's the other symbols for it. There's another symbol that you will see from time to time on calculator. It looks like that, the little mu guy. Okay, so you got really two symbols for the mean, and then each one of these lines to the left and to the right are going to represent standard deviations. So going to the right, this is going to be +1, +2, +3. Going to the left, you got -1 standard deviation, -2 standard deviations, and then -3 standard deviations away from the mean. Uh, and that's pretty much as much detail I want to go into it on this. All your fun starts on the next page, but we will go ahead and talk about the actual problem at hand. You got John Smoltz from 96 for Braves. His fastball was at an average speed of 93 miles an hour, standard deviation of 2, and we're going to go through a series of problems with that information. All right, so here we go. This is going to be a little odd, so let me make this a little bit more fine tip. All right, so again, 96, John Smoltz, average speed 93 miles an hour, standard deviation of 2, and definitely modeled by normal distribution, which is why we're going straight to the bell-shaped curve. So what was the 30th percentile of Smoltz's distribution of fastballs? So if you're doing 30th percentile, remember percentiles always start from the left. So you're going to have 0 way over here. You're going to have 100 way over here as far as percentiles. 30th percentile is going to be somewhere over here, and I'm just going to be very vague about it. Okay, so I'm just going to put it right here, and I'm going to label it. This is my 30th percentile. So if that is your 30th percentile, that means to the left of it is going to be basically 30% of your data. Going to the right is going to be the other part, the difference. So you got 70% going this way. So you'd have the top 70 over here. You got the bottom 30. 30th percentile is going to be right in the middle. And since, well, going back to your tables, if you're going back to the tables, you would want to definitely focus in on the left side anyway, because the tables we use go to the left. So we always want to be thinking about the left side. And if you're doing a table, if you remember, you would change this percent to 0.3000. And then you would go to the table and you would look for the closest percentage to 0.3000. You would get that z-score, and then you would, of course, you could label the z-score, and then you would go to the formula and figure out your missing information. So what I've done here is, since we're not going to use a table, I'm going to show you 3 different ways you can look at this. I will start with the one up here in the top left. So if you notice, it is written really small. I had to squeeze it all in here, but if you're using calculators, of course, they may have a different screen, different looking screen based on how updated it is. This one, you got area off the bat, and so I went in and put in 30%. So I got 0.300. Always want to go with the decimal here, so that's going to be 0.3000. And since they're putting 0 and 1 here, this is the standardized look. So you were thinking automatic z-scores with this. Okay, if you see 0 and 1, be thinking z-scores. If it's set to the left right here, that means you're going to find this whole left side, all right, which is fine. So that 30% goes to the left, so that fits. So if you hit the paste, you're going to get a screen like this one, which is what some calculators will go ahead and start you off with, okay? And then I went ahead and hit enter again, and this is our final answer. So I want you to understand this. If you use the 0 and the 1 right here, it's going to take you to this right here. This is your z-score. So this is your calculator finding the z-score. If you put in, hey, I want the lower 30% based on this, okay? Mean zero, standard deviation 1. So they're going to give you the z-score. So you could, I'm going to go ahead and label this while we got it. Let's make it a little bolder. So the z-score that corresponds with the 30th percentile is going to be negative 0.52. Okay? Now we'll leave it right there. That's my z. Now, what you could do is, once you know the z, then what you would do is you'd come over here to the formula. And we do know that z is equal to our x minus our mean. And we're going to divide that by standard deviation. So if you plug them in, think about this. You're going to have, we know the z is negative 0.52. That's going to be equal to, we don't know the actual pitch yet, minus the mean was 93. We're going to divide that by 2. So once you get to this point, the easiest thing to do is just cross multiply. Just get rid of this right here. Just cross multiply. It will make everything a lot better. So I'm going to multiply with you. So we've got 2 times negative 0.52. Probably didn't need my calculator, but here we go. That's going to give you negative 1.04. But that's going to be equal to x minus 93 now, and it's much more easier to solve. So we're going to go plus 93 both sides. And what we get, we're going to be right there about 91.96. Now, since this is the actual x, this would be the actual pitch. So this is going to be miles per hour. So basically what you're saying with this is, we started with the 30th percentile. We found the z-score to be negative 0.52, and we plug it into the z formula for z, and we get 91.96. That means that right here at this moment, you would have to throw a 90. Why did I write 90? Taking up too much time, coach. All right, so basically this pitch would need to be 91.96 miles per hour to be the 30th percentile. That's what you just did. And that's technically the longer way. So let's go and point out the other ways here, a little faster. Okay, let's go blue. So right here, this way would probably be my favorite. So I'm going to put like asterisk, asterisk, asterisk. This would be the way I'd go, just right to it. Here we go. I'm going to go left, and we know that that area is going to be 0.3000 because you're in the 30th percentile. So I got 0.30000. And I'm going to go ahead and plug in my average. I'm going to plug in my numbers. 93 is my average fastball speed. 2 is your standard deviation. Going to the left, you hit paste. You're going to see a screen that looks like this. And then you hit enter again, and look what it gives you. So if you put the actual numbers in, it's going to take you to the speed of the pitch right off the bat. So the good thing is, if you're doing your graphing calculator this way, plug in your percentage, plug in the actual average, standard deviation, you don't really have to mess with the z-scores. All that's taken care of. Your calculator is going to take you right to that actual pitch speed. Okay, hope that makes sense. Another way you could look at it, well, I'm sorry, I got ahead of me. I got 2 different problems on this one. This one's 30th percentile, this one's 85th percentile. I'm thinking about the next screen. So here we go, let's do the next problem. All right, so for this one, what's the 85th percentile? So if you're in the 85th percentile, of course, going 0 to 100, 85th percentile's got to be over here somewhere. So I'm just going to be really vague about it and just put 85th percentile. Now, that means going to the left should be 85% of my data. Going to the right, just in case you really want to think about going that way, would be 15. So that would be the actual top 15% over here is your bottom 85% if you got the 85th percentile. Going with the decimal, let's convert that over. We got 0.8500. So if I want to do my calculator and be really quick about it, I got 0.8500 for the area. Going to the left, I'm going to plug in my average, plug in my standard deviation. I'm going to hit the paste, I'm going to hit enter, and then it's going to take me right to the pitch. So let me change the color. So you see how that saves you a little bit of time? So right here, the 85th percentile means that pitch is going to be right at 95.1 miles per hour. Okay, and that's it. Didn't have to find a z-score or anything. All right, so that page is good, and we're already at 10 minutes. I better speed this up. All right, here we go. Next situation. So what was the top fifth percent of the pitches? So the top fifth percent. So we got to go way over here, and I'm just going to put this right here. So I'm going to say, hey, this is my top 5% going to the right, which basically means going to the left is going to be a lot more. So we got 95% going to the left, which puts us in the 95th percentile. So it looks like I did two different ways up here. So 95th percentile, excuse me, working with the left side, this decimal will be 0.9500, the area. So I got 0.9500, average, standard deviation, going left, and you just punch that in here and you got the pitch. So that pitch should happen right at 96.3 miles per hour. Okay, so that's doing it one way. And another way, I just flipped the script on this one. Instead of doing the bottom 95%, I did the top 5%. But notice what I changed right here with the calculator. So if I'm going to do the top 5%, my area is going to be 0.05 for the right-hand side. Definitely make sure you got the tail going to the right. I want the right side of this. Same average, same standard deviation. Punch it in there, and you get the same exact answer. So it's just a different take on it if you're using your technology. Okay? All right, last screen. Here we go. Then you got these. So what was the middle 25th percent? So think about this. When you were doing your tables, you pretty much had to, and I'm just going to go ahead and throw in rough estimates. Let's say this is my middle 25, middle 25%. That's going to leave you basically 75% that's going to be both ways. And you could definitely divide that by 2. Hang on a second. My mind's not working. So that means I've got a top 37.5% going this way, and I got the lower 37.5% going this way. Okay. All right. If you want to use your technology, well, let me go back. If you're using your doing this by hand with the tables, you would want to find, of course, your percentiles. This would be the 37.5, well, fifth percentile coming from the left. Going to this one, make sure you add these two together because I want that total from the left for this percentile. So 25 plus 37.5 is going to bring you up to, so this is your 62.5 percentile. So if you're doing this by hand, of course, you would have to find both these percents in the table and run with that. Get the z-scores, plug them both into the z formulas, and get you two different speeds. So watch this. If you're using technology, I want the middle 25%. So I'm going to go 0.25 right off the bat. This is the standardized look. So 0 and 1, which means I'm going to find my z-scores here. Going for the center, because I want the middle 25%. Look at this. It's going to give you, if you really want to know the z-scores, it's going to say, hey, this is going to be negative 0.31, round that up to 2. This one's going to be a positive 0.32. And expect this anytime you're in the middle. You should see that symmetry. So if this one's negative, that one's going to be positive. It should be the same numbers. So if you wanted the z-scores, that's a good way of doing them right there. Again, you're going to plug in 0 and 1 into the calculator. If you really just wanted to go straight for the pitch, you're going to do this. Middle 25, so I got the 25% right here. 93 is the average, 2 is your standard deviation, going for the center. But since I'm using the real numbers, I should get the real pitch values. So the first one's going to be right at 92.4 miles per hour. Second one's going to be right at 93.6 miles per hour. And you're done. So those two pitch speeds would separate the middle 25%. All right, I hope this helps. Good luck.